Hello friends, this is lecture 9 of linear differential equation of higher order, and the form of equation we are going to solve f of t y qx, and the form of qx, that means we are going to solve only those differential equations where qx is either sine ax or cos ax. Okay, in this video we are going to solve only this kind of equations, and the equations we are going to solve are given here 1 2 3. These three equations will be solved here, and please watch all the videos from lecture 1 to this lecture, and links are given in the description box. Now you see, we know that differential equation, solution of differential equation of this form is given by y is equal to complementary function cf and particular integral pi. Okay, so we have already discussed how to find cf and how to find pi if qx is equal to suppose e to the power ax, and if qx is equal to suppose x to the power n. We have already discussed those forms. Now here we are going to discuss what if q of x is either sine x or sine ax or cos ax. So in that case, this pi, we know that pi is equal to given by 1 by f of d q of x into q of x. But in this case, what we're going to do here, pi will be 1 by f of d square, f of d square sine ax, that's going to be equal to 1 by f of minus a square. This d square should be replaced by minus a square. Here it is if sine ax. Okay, similarly in case of cos x also, so if qx is cos ax, then also pi is given by 1 by f of minus a square cos ax. So you may be think why we have taken here f of d square. So it will be clear to you if we solve problem. Okay, so let's start. So now here you see this is the first differential equation we are to solve. So here from this part, if you compare with f of d, and this is our q of x. Okay, so our auxiliary equation will be f of m is equal to 0. If you replace the d by m, then you will get m square plus 6 here, that is equal to 0. And if you solve this equation, then what you are going to have, then you will have m square is equal to minus 6, right, minus 6, and that's going to be I square 6 you can write. So m will be equal to plus minus root over I root 6, you can write this way. So hope you have understood this now. So therefore we can say from this our roots are, we can express this as 0 plus minus I root 6. So m1 is 0 plus I root 6, m2 is 0 minus I root 6. So they are imaginary and complex conjugate of each other. So you can take this one as alpha plus I beta, and this one as alpha minus I beta. Then if roots are in this form, then cf is given by cf is equal to e to the power alpha x within bracket c1 cos beta x plus c2 sine beta x. So this is our cf if the roots are complex. So then if you put the value of alpha and beta here, so here in this case alpha is 0 and beta is root 6. So let's put here. So this term will be equal to 1 because power on e, it is going to be equal to 0 as alpha is 0. So and anything to the power 0 is 1. And so we have got c1 cos, instead of beta there will be root 6 x, then c2 sine root 6 x. So this is our cf. So we have got cf. Now let us find pi. So pi, so in this case we have to take 1 by f of d square, d square sine ax. Here this a is 4 in this case, So we will write here 4x sine 4x, so sine 4x. Then according to the rule, so this d square should be replaced by minus a square. A is 4 here, so it must be replaced by f of minus 4 square. Okay, square is on 4 only, not on the negative sign, so sine 4x. Now here you see this is minus 4 square. So then here you see this d square here in the given equation. You can see in this given equation this d square should be replaced by minus 4 square. So that gives the value of 1 by this. So let me show you how to do that. So if you replace this d square by minus 4 square, then what you will get? 1 by minus 4 square plus 6 into sine 4x. So hope now it is clear how to find this pi. Then so minus 4 square, that's going to be minus 16. Minus 16 plus 6, that's going to be minus 10. So here 1 by minus 10 sine 4x. So this is our pi. So the solution must be y is equal to cf plus pi, and we have got cf here. This is cf and this is pi. So if you put those values here, then you will get the solution. Y is equal to c1 cos root 6 x plus c2 sine root 6 x minus 1 by 10 sine 4x. So this is the solution of this given differential equation. So this is the solution, required solution of this given differential equation. So let us take another example. If suppose here you see in this differential equation there is only d square, isn't it? There is only d square in this equation, given equation. Here you see there is only d square. If this consists d cube or suppose d only, then how to find this value f of minus a square? Then how to find that value? Okay, so suppose let us take another example to understand this. Now let us solve this differential equation. So here we have y is equal to 1 divided by dx is equal to 0 when x is 0. These values are given. So using those values we will be able to find those values, constants c1 c2, whatever we get in the solution, those constants can be found out. Okay, so here you see we can rewrite this differential equation as d square minus 7d plus 6 whole into y is equal to 2 sine thrice x. So here you can see this is not same as the first one, because in the first differential equation we have got f of d is d square plus 6. That's what we have got, and this consists only d square, not d or d cube. This hope you have understood this. So here it contains d square, also d. Okay, it contains d as well as d square. That's why it will be different from this one. Okay, the way we are going to find the pi, that will be differ from this. Okay, not simple as this. Okay, so now let me show you how to find that here in this case. So first let me clean this first. Okay, so our auxiliary equation, the auxiliary equation here, it will be f of m, that's equal to 0, which means here m square minus 7m plus 6 is equal to 0. So if you solve this, this is simple quadratic equation. If you solve this, if you factorize this, then what you will get? M minus 1 into m minus 6. So hope you know this kind of things, how to solve those kind of equations. So it's very simple, so I'm not gonna say this. So here you see m minus 1 is equal to 0 or m minus 6 is equal to 0, which means our one root is 1, another root is 6. These are the two roots, and these are real and distinct roots. So that's why our CF must be equal to C1 e to the power m1x plus C2 e to the power m2x, and putting the values of m1 and m2 here, we will get our CF as C1 e to the power x plus C2 e to the power 6x. So this is the CF we have got. Now let us find the PI. So let us find PI here. So in this case, here you see QX is 2 sine thrice x. So that's why in this case our PI will be equal to 1 by f of d square 2 sine thrice x. So here value of A is equal to 3. So that's why it's going to be 1 by f of minus 3 square. So let us write the 2 here, sine thrice x. So that is our PI. So if you put so here you see, here we have taken f of d square. So that's why we can replace this d square only by minus 3. So our PI will be equal to 1 by here we have 2 by minus 3 square minus 7 d plus 6, then sine thrice x. Then now here it will be 2 minus 9. So let me calculate here. So minus 9 minus 7d plus 6, and that's going to be minus 3 minus 7d. That's what we will get here as a denominator. So that's what we have got. So if you take the minus common, then it will be 3 plus 7d, isn't it? So we can write minus 2 by 7d plus 3 and sine thrice x. So here you see we have got, this is f of d. This is not f of d square. So in order to make it f of d square, so what we're going to do, as there is 7d plus 3, so we are going to multiply both the numerator and denominator by 7d minus 3. So let us do so. Then what we will get? So what we will get, so let me clean this first. 7d plus 3 we have here. So let us multiply 7d minus 3 with both numerator and denominator. Then what we will get? Minus 2 7d minus 3, and if you multiply this with this denominator, then you will get minus 7d whole square minus 3 square, and here it is sine thrice x. So now let me scroll down the page. So here you see our PI will be minus 2 into 7d minus 3 by here 49 d square minus 3 square is nothing but 9. So sine thrice x. Now what we're going to do, now here we have got d square. That's why now replace this d square by minus 3 square. Then what you will get? Then we will get this one is equal to 441. Not only 441, minus 441 minus 9, that's going to be minus 450. Okay, minus 450, that's what we will get. So now PI will be our, so let me scroll down the page. Okay, minus 2 into 7d minus 3 minus 450 sine 3. Okay. So if you cancel this one, then here you will get 2 to 5. So now here you see in the numerator there is d. D means dy by dx, isn't it? So instead of y you can write d by dx, and if you operate this function by this sine thrice x, then you will get 3 cos thrice x. So then our numerator becomes 7 into 3 sine, sorry, not sine, cos thrice x 3 sine thrice x 25, sorry 2 to 5. So that's what we have got. So now let me scroll down. So here you see from these two terms in the numerator we can take 3 common from both. Okay, after taking 3 common we can cancel the denominator by 3, then here we will get 75. So that's why our result becomes equal to 7 cos thrice x minus sine thrice x by 75. So this is our pi, which can be written in this way also: 75 1 by 75 within bracket 7 cos thrice x minus sine thrice x. That's how we can write. So here you see we have got CF here. This is our CF, and we have got this pi also. This is our pi. So that's why our solution of this equation will be, therefore solution is y is equal to, so CF is C1 e to the power x plus C2 e to the power 6x plus 1 by 75 into 7 cos thrice x minus sine thrice x. So this is our solution. But also given that y is equal to 0, sorry not 0, 1, and dy by dx is equal to 0 when x is equal to 0, So if you put here 1, y is equal to 1, then what you will get? So y is equal to 1 when x is equal to 0. That's why these two will be 0. Okay, so then you will get C1. On putting 0 here, x is equal to 0 here, then this term becomes 1. So we have got C1 and C2 here. Then 1 by 75. So if you put 0 here, then cos 0 is 1 and sin 0 0. So we'll get 1 by 75 here in this case. So that's what we have got. Now as this is 1, so 7 into 1 here you will get. And that means simply you can write 7 by 75. This is suppose equation number 1. Again, dy by dx is 0 when x is 0. So from here we can find dy by dx. If you find dy by dx, then what you will get? Dy by dx will be equal to c1 e to the power x plus 6 c2 e to the power 6x plus 1 by 75 minus 21 cos, not cos, sine thrice x. That means we are differentiating this result with respect to x. Okay, it's an every term differentiate with respect to x. Okay, then plus, sorry not plus, minus 3 cos thrice x. So then it's become equal to, here you see when x is equal to 0, this dy by dx is also 0. So from this equation, putting x is equal to 0, we get 0 is equal to c1 plus 6 c2 and minus, if you put 0 here, this term will be 0 and this term will be 3 into 1. Okay, so because cos 0 is 1, so then there is minus sign, so it's become minus 3 by 75. Okay, minus 3 by 75. That's what we have got. This is equation number 2. Now let us solve these two equations in order to get c1 and c2. Okay, so first what we can do, we are going to subtract 2 from 1. So equation 1 minus 2, then 1 will be equal to, then this c1 will be cancelled on subtracting these equations. Then c2 minus 6 c2 plus 7 by 75 minus 3 by 75. That's what you will get. So now here you see what we're gonna get here. This is 1 minus 5 c2 then plus 75, 7 by 75 plus 3 by 75. So let us simplify this. 5c2, then here 75, 7 plus 3 minus 1, that's going to be equal to 10 minus 75 by 75. So here c2 is equal to 5 by 5 into 75, it is minus 65. Then let us cancel this one, so that's minus 3. So here we have got c2 is equal to minus 13 by, not minus 3, minus 13 by 75. So this is the value of c2. Now let us put this value of c2 here, or you may put in equation number 1. Okay, so putting c2 is equal to minus 13 by 75 in 1. So putting this value here in equation number 1, let us put c2 here in this equation. Then what you will get, 1 is equal to c1 plus not plus here, as we have got minus 13 by 75, so let us write minus 13 by 75, then plus, so what we have here, 7 by 75, so 7 by 75. So if you calculate these two, then what you will get, this implies c1 is equal to 1 plus 13 by 75 minus 7 by 75, and that's LCM will be 75 plus 13 minus 7, and that's gonna give you 27 by 25, or you may write 81 by 75, and if you cancel this 2 by 3, then you will get 27 by 25. So that's why c1 is equal to 27 by 25. So now you see we have got the value of c1 here, and we have got the value of c2. This is, so using these two values in this solution, this was the solution of this given equation that we have taken here. So if you put c1, value of c1 here and value of c2 here, then our solution will be, y is equal to, so c1 we have got 27 by 25, then here we have e to the power x, next term is plus c2, here you see c2 e to the power 6x, so c2 is nothing but what, minus 13 by 75. So here this will be minus, so minus 13 by 75 e to the power 6x, and the next part is, the remaining part is this, so this is the remaining part, 1 by 75, 7 cos thrice x minus sin thrice x. So let me write here, 1 by 75, 7 cos thrice x minus 3 sin, sorry, not 3, only sin x, sin thrice x. So this is the solution of the given equation that we have solved. So hope you have understood this. Now, so this is the last differential equation we are going to solve. So here auxiliary equation will be f of m is equal to 0, which is equal to here m cube plus 1 is equal to 0. So factorize it. In order to factorize this, we are going to use this identity here. We are going to use this identity, a cube plus b cube, that's equal to a plus b into a square minus ab plus b square. Let us use this identity. So we will get m plus 1 into m square minus m plus 1 is equal to 0. So product of these two equal to 0 means either it's any one of it's 0 or both of them 0. So m plus 1 is equal to 0, or we will get m square minus m plus 1 is equal to 0. So from here we will get one root, that is m1 is suppose minus 1 here. So this is one root, and other roots will be obtained from this equation. If you solve this equation using quadratic formula, then what you will get, m is equal to minus 1, sorry, not minus 1, so minus 1 plus minus root over minus 1 square 4 into 1 into 1 by 2 into 1. So using that, here it will be 1 plus minus 3, here we will get 2. Okay, and here you see minus 3 can be written as I square 3, so that's why so other two remaining roots becomes m2 and m3. m2 is 1 plus I root 3 by 2, and m3 is 1 minus I root 3 by 2. Or you can write half plus 1 by root 3 I root 3 by 2, and m3 is equal to 1 by 2 minus I root 3 by 2. So that's what we got. So these are the three roots we have got, this one and this one. So these are the roots of the auxiliary equation. This is the auxiliary equation. So here you see this is real roots, m1 is the real roots. So that's why for this our CF should be C1 e to the power minus x. Okay, and here you see these two are complex and conjugate roots. So that's why if you compare with alpha plus I beta, so here alpha is 1 by 2 is alpha and beta is root 3 by 2. This root 3 by 2 is beta. Alpha is half and root 3 by 2 is beta. So for complex conjugate, what should be the CF? For this kind of roots, alpha plus minus I beta roots are complex conjugate, then CF should be e to the power alpha x within bracket C1 e to the power. So we have already used here C1, so let us take C2 here. C2 e to the power, not e to the power, cos, sorry, not a to the power, cos beta x plus C3 sine beta x. That should be the CF. And this is for this complex part, and for this real part, here you see. So we have got here m1 is equal to minus 1, which is real. For this case, this is our CF. So CF of this equation will be C1 e to the power minus x plus this part. Okay, so C1 e to the power minus x plus, if you put the value of alpha here, that e to the power half x, because alpha is here 1 by 2 and beta is root 3 by 2. C2 cos root 3 by 2x plus C3 sine root 3 by 2x. So this is our CF. Now let us find PI. And before that, see one more thing. This 2 cos square, you see, this 2 cos square x, it can be written as cos twice x plus 1. Cos twice x plus 1. This is a trigonometric identity. Hope you have understood this. So this one can be considered as e to the power 0 into x. So if qx is equal to e to the power 0 into x, then pi is equal to, pi will be equal to 1. That's very simple. But for this part, we are going to use this pi is equal to 1 by f of d square cos twice x. We are going to use this. Okay, so hope you have got this. Now let me clean this piece first. Okay, let us find pi. So pi will be equal to 1 by f of d square, f of d square cos twice x, and then plus we will get 1. So pi for this e to the power 0 into x, that's going to be 1. That's very simple, isn't it? Because you see, if qx is equal to e to the power 0 into x, that means 1, then pi is equal to 1 by f of 0 into e to the power 0x. So f of 0, if you put here 0, here you see in the given equation, this is f of d. If you put here 0, you will get 1 here, 1 by 1, and e to the power 0 into x is again 1, so it's become 1. So that's why it is 1. So hope you got this part. Now in this case, a is 2 twice x, so here 2, so we will get 1 by f of minus 2 square and cos twice x plus 1. And here you see, in this equation there is no d square term, so this d cube can be written as d square into d plus 1, isn't it? So before putting this minus 2, let me do one thing. So just let me write the f of d first, that is here d cube plus 1 cos twice x plus 1. So let me scroll down the page. So here 1 by this d cube can be written as d square into d plus 1 cos twice x plus 1, and this d square can be replaced by minus 2, as there is 2, so minus 2 square will replace this d square, because you know when q of x is equal to cos ax, then pi is equal to 1 by f of minus a square cos ax, isn't it? So here this d square will be replaced by minus 2, so 1 by minus 2 square, not minus 2 only, minus 2 square into d plus 1 cos twice x plus 1, and that's gonna give you here minus 1 by 4d minus 1. That's what you will get, cos twice x plus 1. So here it is now d. In order to get f of d square again, so what we're going to do, we are going to multiply both the numerator and denominator, by 4d plus 1. Okay, then what you will get, then our pi will be equal to minus 1 by, if you multiply here this one 4d plus 1, and here also 4d plus 1 with the numerator and denominator, then here as a denominator you will get 4d whole square minus 1 square. That's what you will get, cos twice x plus 1. So that is our pi. So now you see, we're gonna have here minus 4d minus 1, and this is 16d square minus 1 cos twice x plus 1. So again we can replace this d square by minus 2 square. Okay, so if you replace this d square by minus 2, then what you will get, minus 2 square means minus 4, and if you multiply with 16, then you will get minus 64, and we have minus 1 here, so that's why minus 1, that means minus 65. Okay, so minus 4d minus 1 by minus 65. So you can multiply both numerator and denominator by minus 1, then it will be this one, 4d plus 1 by 65. That's what we will get. So hope you have understood this. And cos twice x plus 1, so as there is d, which means this differential coefficient d by dx, and if you operate this cos twice x by this operator, then you will get minus 2 sine twice x, isn't it? So that's why what we have got here, 4 into minus 2 sine twice x plus cos twice x by 65 plus 1. So this is our pi. So that is equal to minus 8, or you can write this way, 1 by 65 minus 8 sine twice x plus cos twice x. You can write this way, or you can take the minus sign common, then what you will get. So this will, taking minus common, we have got minus 1 by 65, 8 sine twice x minus cos twice x. So this plus 1 should be written here. This is our pi. So we have got now pi, and we have also got cf. So this is the cf we have got here. This is cf. So let me write the solution now. We know the solution is given by y is equal to cf plus pi. So our cf, we have got c1 e to the power minus x plus e to the power half x. Then let me check it again. This is the term within bracket. Okay, so this is c2 cos root 3 by 2x plus c3 sine root 3 by 2x. Then plus pi is this part. This is the pi. So here you see as there is negative, so let me write here minus. So minus 1 by 65 8 sine twice x minus cos twice x, bracket close, then plus 1. So this is your solution. This is the solution of this given equation. So hope you have understood, and if you have understood, then please share the video with your friends and subscribe the channel if you are new to my channel. And thank you for watching this video.